Hello once again, welcome back to the Ivory Tower Collections. In today's video, I'm going to show you the process that I use for installing what is currently the best video upgrade possible for the Atari 7800 console. And what is that upgrade, you may be asking yourself? Well, it involves the use of this little guy right here. Let's check it out. The upgrade that I am specifically talking about with this little guy right here is with what's known as Lumacode. Specifically, this is the Digitizer for the 7800, which is one of two main components required in order to use Lumacode and provide you with an excellent output from the console. I've already gone into another video that talks about Lumacode and essentially how it works and what its advantages are, and just kind of a real brief overview on how to use it. But in a quick summary, Lumacode is a new video signal output that's been developed by a very talented guy in Austria who goes under the name of Copper Dragon. And essentially, Lumacode is a composite level video output that provides primarily luminance, hence Lumacode in its name, but also additional information embedded within it that is then converted and eventually allows us to have full digital HDMI output with audio. Obviously, it doesn't work on its own like this. There's another device that's required for this, which is this little guy right here. This is an RGB to HDMI converter. And this one specifically is in a new 3D printed case shell from OG Hugo's shop, which is pretty cool. So in combination with this little converter and this board, it is able to provide us with a full HDMI output using a HDMI port from the RGB to HDMI converter. So in today's video, I'm going to go through the process I use to specifically install this Digitizer into the 7800 console and just kind of give you a couple of tips and some ideas on how you might want to install this as well, because once this is in place, this is absolutely fantastic. So what tools will you need for today's project? Well, as is common in all of these projects, it seems, you're going to need that trusty number 2 Phillips screwdriver. That's going to be for opening up the case shell itself. You're also going to need possibly some small tweezers of some sort just to kind of help you with your wiring, just to kind of get it where it needs to go. You're also going to need some small needle nose pliers like this, or I also use a specific tool that came with a soldering kit like this, which comes with a chip lifter on one end, and then also this little cylindrical end here that's got a slot through it. And I'm able to use that as well for the specific purpose of what you can also use the needle nose pliers for. The other thing you're going to need the Digitizer itself right here. Now, in addition, I need to mention a couple of things. When you receive the MARIAdigitizer, it's probably going to come with a cable harness like this that just kind of plugs off as some header pins that have been put onto place. The earlier MARIAdigitizers just had wiring that was soldered off of this, but for some reason, I guess the newer ones come like this, and that's fine. However, because of the way NTSC consoles are done and because of the way that you're probably going to want to do your install, this cable harness may or may not be useful to you. So just keep that in mind. Also, depending on where your output connections will be for Lumacode, the wiring may not be long enough and you may have to use some other solution. It will also probably come with an RCA jack, like this one here. And this one here is it's like a gold-plated RCA jack that happens to have a black center on it. That's just what he sort of provides. And I think the general idea is that if you have the whole wiring set up like this, and you install this RCA jack somewhere on the console, then he was trying to provide an easy way of essentially having a no solder solution by allowing you to clip one edge of your alligator clip to the center pin of the RCA jack. This would be for one portion of the signal. And then you would clip the other end of the RCA jack onto the ground lug here, or the ground tab off of that RCA jack, which would provide the grounding needed for the signal as well. I think that's the general idea, but just for reliability in most of my projects, I would end up soldering all of this together if I was going to use this solution. And that's pretty much what you're going to probably get in the kit. If any of that changes, then I apologize. That's just what I received at the time of this video. Now, in addition to the MARIAdigitizer that I've just shown you, you're also going to need an RGB to HDMI converter box like this one here. And that's again because the whole purpose behind this device is to take the signals coming from Lumacode, which would be here on a 3.5mm jack on the RGB to HDMI, and it converts the signal internally and provides a full digital HDMI output from the mini HDMI port here. And in this particular case, I'm using the RGB to HDMI converter, which has the embedded audio capture board already in it, which makes it handy to already get the audio and everything in one place through the HDMI and not have to deal with an external mixer or something to that effect. Pretty cool. Another thing you're going to need, and this is not going to come in the kit, but I would strongly advise it, is to get yourself a 48-pin precision pin or machine pin or turned pin, there's all kinds of different terms for this, socket. And the reason for this is because the MARIAdigitizer boards use rounded pin headers attached on the bottom side. And because of the way that this gets installed, which is essentially directly into the console, you'll also notice that the Digitizer also has precision pin socket on the top of it. That's for the Maria IC chip to plug back into. But because it's using these rounded pins, and because NTSC consoles, most of them do not have sockets in them, or if they do, they're of the dual wipe type, which looks similar to something like this. While you can use a socket like this and it will work, it won't seat in there very strong. And you'll find out that you could have reliability issues with connectivity, or the board might try to pop out of those sockets. So again, I strongly advise getting a hold of a 48-pin socket with the turned pin, machine pin, precision pin, whatever you want to call it. What else are you going to need besides that? Well, depending on the project and however you plan to do the output, you could use, again, the included RCA jack, but this would require having to potentially drill a hole into your case shell somewhere, like a 1/4-inch hole, which is the typical size for RCA jacks like this. But there are some other alternatives you might want to look into that might not necessarily require having to drill a hole. And that would be using something like a small 3.5mm type jack, like this one here, or possibly even like this one here. I tend to use these as well. And what you can do is you can use something like this and retrofit it inside of the RF modulator box of the 7800. Or in fact, you could cut the wiring on the RCA jack end and solder the wiring from Lumacode directly to it, and then you could just use this as your Lumacode output. But keep in mind that would only be video. You would still have to handle some way of doing audio. So that's why, you know, this is just another option to look into. And I'll go into more details towards the end of the video when I go into the actual output side of things on these options a little bit more, especially this one using the RF modulator. It can be kind of tricky to open these up, but it is a great way to use this as a mounting base for something like a small 3.5mm jack to provide you with your video and audio output without having to modify or alter your case shell plastics in any way. All right, with that, let's go ahead and take apart a 7800 and take a look at the area of focus that we're going to need to work in. Let's go ahead and take this 7800 apart. So what you're going to want to do is, first of all, be very careful when handling a 7800. The plastics on most 7800s are quite brittle these days, especially as old as they are. So just again, be aware of that. Now I've got something kind of a soft surface here. And I'm just using this to help protect the face and plastics of the 7800 a little bit. Now there's a total of 5 screws that have to be removed. You've got 3 along the front edge, 1 in each corner and 1 in the center, and then there's 2 additional ones in the back. Now I've already removed 2 of these screws in the back just to kind of speed things up a little bit. But one thing you need to be careful of when you're removing the screws on a 7800, especially if it's never had the screws removed before, is that they're going to be in there kind of tight. And you don't just want to wrench it down really quickly to try to break them loose, because you can in fact break the plastic on the boss posts on the inside when doing that, and that would not be good. That would make reassembly of the system much more challenging and probably have to repair the plastics in the process. So again, that's just something to be careful of. Once you have all the screws removed, we can go ahead and flip the system back over again, and the top will just come right off like that. You can set that off to the side because you're not going to need it for now. And now here we are looking at the main guts, or the main internals of the North American 7800. This is a pretty typical setup. Now you might see some things that look different on this particular 7800 in this video versus what yours looks like. Ignore that. I've already done some work and upgrades on this 7800, and it's the Lumacode side that we're focusing on today, and so everything else that you might see doesn't matter. But to remove the main board out, I basically lift it up from the back side first, and then I pull it away from the front edge like that so that the controller ports will slide out along with the difficulty switches, and then the whole assembly will just come right out. From here, I'll set it back down, and I can put this bottom shell away. Okay, so here we are looking at the rest of the system, and we have our RF shielding in place. Now this RF shielding is going to have to come off. There is a whole bunch of little tabs that are scattered around the entire section of the RF shield that essentially hold this top section and the bottom section of the shielding together. And those are all going to have to be loosened up in order to get to the rest of the system. Okay, so here we are. I've got it zoomed in a little bit on the front edge, and you can see just a little bit how we've got a little tab here and there's a little tab over here. Now I've already straightened these tabs out, so let me show you some of the tabs on the other side over here. Now here's some. Oh yeah, you can see these a whole lot better. So these tabs are actually twisted just a little bit, and that's to secure, again, the top portion with the bottom portion. So this is where the little needle nose pliers come into place. So you can just take them like this and just carefully twist and straighten those tabs up. Now you do need to be careful because, like the rest of the console, some of the metal on these RF shields is kind of brittle, and I've actually had one or more of these little tabs just kind of snap off in the process of doing this. Now again, I'm going to be using my little soldering tool kit here because this comes in real nice and handy for being able to undo these. I've now loosened all of the tabs all the way around on the RF shielding, and now that I'm going to be taking these two sections apart and handling the RF shielding a whole lot more, in addition to the rest of the electronics, I've got some gloves on to just kind of help minimize getting my paw prints all over everything. So once you've got all those little tabs straightened out, the easiest way I've found to separate the two halves is to turn the system over so that you're looking at the bottom side of the shield, and then use something like a small flat-bladed screwdriver or something similar. And what you're going to want to do is there are some notches, there are some openings along the bottom of the shield. You're just going to want to take the screwdriver and just kind of lightly pry up like this from the bottom and go all the way around to slowly work out and walk those little tabs loose from the shielding. So again, I'm just going to lightly come around and just get this little flat-bladed screwdriver underneath, and I'm keeping it around the ground sections, the ground trace on the bottom, so that I don't really scratch anything up on the board, and I'm just being very careful with it and just kind of lift it up like that. So once that's all freed up, we can now set this off to the side somewhere. And now at this point we can take the whole system and turn it over, and you'll want to be careful because the top shield is no longer held in place by anything, so it will now just come right off. Okay, here we are looking at the main board of an Atari 7800, and the primary area of focus is going to be right here. This is the MARIAIC chip, and this is where the new digitizer will be installed to provide us with our Lumacode output. So again, like most typical North American 7800s, none of these IC chips are in a socket, so I'm going to have to desolder the MARIAIC chip. Now there are a lot of pins on this. It says a 48 pin IC. So it can be a little bit of a challenge. You just got to take your time. Now, there's a couple of ways that you can desolder items like this. You can use one of those old solder suckers or a hand pump. That will work. You just got to be careful and go pin for pin. You can also use something like that in combination with some desoldering wick to help you get rid of the extra solder. I'm going to cheat a little bit and be using my Hakko FR300 here to get that loose. One thing that will help when removing the MARIAIC, again, we've got 48 pins here, there's quite a few to have to go through and desolder, is to actually add a little bit of solder to each one of the pins first. This just helps to basically provide some fresh solder and will also allow it to mix in and more thoroughly come through the vias whenever you're using the desoldering hand pump or your wick, or in my case, my desoldering vacuum pump here. So yeah, that's the first thing I'm going to do, is to go ahead and apply a little bit of fresh solder to each of these pins. Once you've gone through and desoldered the pins, it's always a good idea to go back and check to make sure the pins move around freely within the vias. I'll show you what I mean. I just take my little tweezers here and I just try to wiggle the pin, and if the pin moves back and forth fairly freely, then it's a pretty good chance that it has removed all of the solder all the way through. And I'm just going to do this all the way across for both sides. And you'll probably find that while you're desoldering, if it's doing a really good job or if you're really getting the solder removed properly, then the chip itself will start to feel loose, and you might even see other pins shake. It's like you can see here. So yes, the desoldering on this one worked quite well. Here is the Maria IC chip, and because I already happen to know it's loose, it's just going to pull pretty much right off the board. Like that. Now, one thing that needs to be done at this point is, because there could be some excess solder still left on the IC chip, you're going to want to clean these legs up a little bit. You might also have to straighten them out. That's because you're going to end up reseating this back into the digitizer board a little bit later on. At this point, it would now be a great idea to go ahead and clean off the actual area where the chip was located. Just because, you know, as is typical with all Atari stuff, it seems like there's always quite a bit of residual flux that gets left over on the boards. So I'm just using some electronics grade alcohol here. This is 99.9%, and a Q-tip. And I'm just going through and just going over these pins. And you can see there's quite a bit of brown and orange coming off on this Q-tip. So yeah, there's quite a bit of old residual flux left on the board. Might even require multiple Q-tips to get it cleaned up. And I will do this on both sides of the board, by the way. And you'll probably find that the bottom side of the board is probably dirtier than the top, and that's just because that's where most of the flux from the factory was applied when soldering these chips into place, and so that's where most of the residual flux will remain. And now the surfaces are nice and cleaned up and ready for the digitizer to be installed. I'm now ready to install my replacement socket onto the main board of the 7800. Now, there is orientation to be aware of. If you look closely at the silk screen on the 7800, you will see that right here where it's got this label for U1, that there is an outline of the chip, this white thin rectangular line. On the left hand side, you will see that it's got a little bit of like a little notch where it curves in. Now that's important because when you go to install your new socket, it too will have a notch on it. So I'm just going to just kind of lay it into place there. And if you look closely here, you can see that there is a little bit of a curved in notch on the socket. And again, that's just to help orientate and to mesh up and make sure that everything is matching when you go to put it into place. So what I'm going to do now is I'm going to go ahead and solder this socket into place on the main board. I now have the new replacement socket in place, and we're ready to continue on with the rest of the installation. So from here it's pretty simple. You just have to take the MARIAdigitizer, and similar to any other IC chip, what you're going to need to do is you're going to need to make sure that you orientate this properly when you go to insert it into the replacement socket. Now, it's not as easily marked on the digitizer, but there is a tiny little notch right down here in the lower left-hand corner on the socket that Copper Dragon uses. And this is again denoting where pin 1 is, and to match up with the notch that we have on our replacement socket and as silkscreen on the PCB. So what I'm going to do is I'm going to carefully go ahead and align this up into the socket. And again, this is why I use the rounded pin type, is to make sure everything meshes up. And you're just going to push it down into place, just like that. And now if we take a look, it should be seated in there all the way across. Now what we need to do is to reinstall the Maria IC chip back on top of the Digitizer. Now you can see that Copper Dragon has designed the board to fit pretty much perfectly. There's no other components that really get in the way except for probably maybe these transistors right here. But for the most part, I've never really seen them be in the way. But if they were, then you might have to carefully desolder them and maybe reorient them or bend them down out of the way if for some reason they are in the way. But again, I've not seen that. So now to reinstall the Maria chip back onto the Digitizer, same as before, I'm going to match up that notch that's on the left-hand side here and match up again with the Digitizer. So we're just going to put it into place, and hopefully the pins will match up. It looks like they match up on one side, but they're not quite matching. Ah, there we go. And then very carefully, I'm going to push the whole assembly in down. There we go. Now the Maria chip is back installed. It's back in circuit with the Digitizer. And from here, we're pretty much just about done, because now all that needs to be discussed is about the outputs. Now I had mentioned before that you've got these little header pins that come off of the Digitizer. So you can kind of see them poking off there. And they are marked, because one is the ground output and the other one is for the Lumacode. So the pin here that's closest to the edge of the PCB is the ground, so that's marked with G and D, and then the one that goes towards the inside portion of the board is marked as Lum or Lumacode. There are cable harnesses that come with these, and it doesn't really matter which way you orient this whenever you go to plug it in, as long as you are paying attention and you know which wire color is going to which. But again, this is where we need to talk about how the output needs to be done, because these cables, these harnesses, come with these little tiny alligator clips on them, and that may or may not be useful for you. Again, I think the idea was that you could basically take the RF modulator housing off and maybe perhaps clip it to the inside connections, but honestly, it's not that easy getting the RF modulator off the board and also to dissect it and gut it completely apart. So, you know, you might want to use your own option on this. I will show you here in a little bit how to remove the RF modulator, and also how you can take it apart internally so that you can actually either reuse the RCA jack that's already on the modulator housing for your Lumacode output, or how you can remove it completely and replace it with something else like a 3.5mm jack, which can be used to provide both the video and the audio simultaneously from that spot. The RF modulator is held in place usually with 4 large soldering anchor points on the corners, although I have seen some 7800s that only have 2 of these soldered down and the other 2 are open. Lucky you if you have that. And then you also have these 4 pins right here, which are the actual pins for the RF modulator section. So you'll need to desolder all of these items off the board in order to remove the RF modulator. Again, you don't have to remove the RF modulator. You could drill a hole into the shell and install either some RCA jacks for Lumacode and audio that way, or to use something like a jack that can provide both. So I'm going to show you how you can do it on the RF modulator, and then I have my own PCBs that I've designed for using in a 7800 to make this a little easier for me. There we are. RF modulator is removed and the area has been cleaned up. I have here an RF modulator removed from a different 7800. This is not the same one, but I'm going to use this one as an example to show you how to take the RF modulator apart in case you do want to reuse either the RCA jack for your Lumacode or if you want to install a replacement. So with the box fully removed, the first thing you're going to need to do is to get this bottom plate off. Now, depending on how much solder was used in the setup, these can be kind of difficult to remove. So I do sometimes find that I have to use a small tool to help me get in there and pry up the metal housing a little bit. There we go. Now, there's not much to the inside of the RF modulator. It basically just has this one PCB here that extends out through the back, and also the RCA jack that has been soldered internally. The grounding for the RCA jack actually comes from the outside of the housing of the RF modulator box. So there's really just one wire that's been attached to this. In most cases, you're also going to find that this RCA jack is probably soldered to the inside of the RF modulator box. So again, you'll need to use quite a bit of heat with your soldering iron and possibly your desoldering braid to try to soak and wick up as much of that as you can. In my particular case, I'm able to use, again, my desoldering gun to get around that and to remove it. Another thing to keep in mind is that it is also usually soldered into place here and here. The actual PCB will be soldered to the metal housing in these two locations, so you would also need to remove this solder as well. There might be one more spot of solder that's left inside of the RCA box, and this one can be really tricky to get to. But sometimes, and I believe this one is the same way, there will be a little bit of solder right in here, right on the front leading edge next to this little anchor post here off the housing. So that will also have to come off, and I should be able to get that with my desoldering gun. There we go. So again, not the easiest thing to take apart and remove, but it can be done. So from here, it's a matter of just getting the RCA jack out. Now, again, if you've removed all of the solder that was going around the edges of it, then in most cases, it will probably, you'll be able to use like some small needle nose pliers, carefully grab around the base of it, and just kind of give it a little bit of twist and work it out. And then at this point, you've got an opening already in place where you could install a replacement jack and then run the wiring back out through one of these holes here on the side. So yeah, there are options, and using the RF modulator box and housing is a real good way to go ahead and install a replacement output for the Lumacode. All right, so what's another option? Well, the particular option I'm going to use is still going to involve the section for the RF modulator, but I will not be using any of the old parts of the RF modulator itself. Let me show you what I'm going to do instead. So my solution for this particular 7800 that I'm working on is going to be using something a little bit different for the AV output. Specifically, I designed a PCB that would actually fit in place of the RF section and provides a 3.5mm jack here, along with an extra capacitor here to help with some of the audio filtering. This way, all that needs to be done is to simply solder this board back into place, and then you can just run the Lumacode and ground wires from off of the actual Digitizer board and solder them down into place on this new PCB. So it just kind of makes it nice and tidy and straightens it up, and this is reversible if need be. But again, this isn't something that everybody's going to be able to have access to. This PCB is something I pretty much only offer exclusively when people have commissioned me for services. But that's what I'm going to be doing in this particular installation. That's why I wanted to show you the other options as well, using the RF modulator housing box as an example. That just takes us to how the audio is going to be handled, because similar to other AV upgrades, the MARIAdigitizer does not have anything in place to handle the audio. So what do we need to do about that? Well, there are again a couple of things you could do. Let's say you want to keep the RF modulator in place and you want to use it. Well, then what you would need to do is you would need to come up with a system that allows you to properly tap the audio where needed and route it to a separate RCA jack or whatever you wanted to use for audio. In a situation like that, you're going to want to set up something like this. Now what this is essentially a replicated set of resistors identical to the resistors that are on the main board in the audio section, combined with a capacitor for additional filtering before it goes onto the output jack for the audio. So the easiest way to go about this in something like this would be to get, again, another 6.8K and an 18K resistor, which will match the ones that are located for R6 and R5, and then you would just solder those at the base of those resistors. And then your audio output wire would run off to wherever you needed to. Another option, and what I'm going to do in this particular case, is because the RF modulator is not being used, I'm going to desolder the north side legs, or the top leads, of R5 and R6, which I've already done here, so I'm going to go ahead and pull these loose. I'm going to twist the two leads together and combine them, and then I'm going to run a separate piece of wire off of the two leads, and that will go into an audio input pad on the replacement PCB. Again, I already have another capacitor here for that purpose. So that's just to help me a little bit on the wiring. So that's really the two options that you can go with for audio. Again, in this case, I'm going to just reuse the resistors that are on the board since they're not on the RF modulator section anymore and it won't be there. I can just reuse these. So I'm going to go ahead and take these out, flatten them out, twist them together, and go from there. Now what I'm going to do is I'm going to go ahead and get this PCB soldered down into place where it needs to go, and then be able to tidy up and get the final wiring done. So there's the completed setup as far as for the Lumacode, and in this particular case also the audio. So again, with this PCB in use, I just have my ground going to a ground point, as well as the Lumacode signal going to a Lumacode, and then my audio goes here, and then all of that combines where it needs to into this 3.5mm headphone type audio jack. At this point, we should be ready to be able to put this back into the case shell just enough to be able to give this a test and see how it looks. So let's go ahead and do that. I will put the RF shield housing back on this a little bit later, but for the purposes of just doing an initial test and fitment, I just want to go ahead and just put it back into the shell like we see here. I'll go ahead and get the top put back on, and now we can see how it looks from the back. And you can see that that new 3.5mm audio jack is pretty much dead center with the RF opening. And that will make it very easy to be able to plug a cable into it from the other end and into the RGB to HDMI converter for the Lumacode video and audio to work. And again, very nice elegant solution that doesn't require any alterations to the case shell. What I'm going to do is I'm going to go ahead and button this back up, and I'm going to go over to the test bench, change the camera, and we'll take a look over there to test it out and see how it looks. I now have the 7800 put back together and reconnected up to my sample test lab setup here. It is going through an actual 3.5mm to 3.5mm audio cable here that's plugged into the new port from the RF opening into the RGB to HDMI box here. And then in turn that goes into my capture device you can see off to the side, and we see the menu for the RGB to HDMI here on the screen. And if you look closely, you can see that I do have it selected currently on the Atari 7800 Lumacode profile. I'll have a link in the video description on the GitHub to get the latest information, but I believe at the time of this video, this profile is still not part of the default RGB to HDMI software set. So it is something you'll have to get separately from Copper Dragon's GitHub. So I already have it in place and enabled, but I do want to go over some of the options really quickly just so you can kind of see the starting point from what I'm using here. So as an example, I am using the enhanced 4:3 on the 16:9 integer scaling. That is the default, so I don't normally change that in the case of the 7800. In the section for the geometry, it should pretty much already be set to what you see here, but one option I want to mention is the maximum vertical height adjustment. Now by default, this profile sets it to 250, and that will actually work great for pretty much every game, as near as I can tell. However, you will notice that some games may produce extra pixel noise along the bottom or top portions of the screen. That's because that was screen information that's normally in the overscan that you can't see when it was being used on a CRT. So if you're playing a game and that does happen to bother you, then you might want to change this maximum setting down to something like, say, 238 or 236, for instance. Now, the reason for why it defaults to 250 is because there are a few games, especially some newer ones, that do write actual gameplay screen data in the overscan sections. The more recent Tiger Heli released for the 7800 is an example of a game that does this, because the score detail information tends to be in the overscan, and if you set that to 236, you'll find that some of that data is actually cut off. So again, defaults to 250. And then the other thing, of course, is in the sampling menu, you may find that you may have to make some changes here. The current settings I have in place seem to work well for me. In this case, it's sampling phase 6, although anything from 5 to 7 does produce 0 artifacts according to the auto calibration. The other changes that you might have to adjust are down here in the DAC settings and the DAC voltage offsets. So you can see my settings here. I've got it set for 62. I've got this one set for 46 on DAC B. And then the DAC E sync is a good one that you may have to mess with. I believe it defaults to 10 on the profile, but I have found that settings between 12 and 15 usually work best for me. So again, that's going to be a mileage may vary kind of situation on what works best for you and your particular cable setup. But those are just some options and some items you may need to be aware of. Something else to keep mindful is that the RGB to HDMI does not auto switch when playing 7800 games and then switching over to 2600 games. So you will have to physically switch the profile when you go to select a different type of game. In this case, let's say you're playing a 7800 game, in which case the 7800 profile is fine. But if you're going to play a 2600 game, then you're going to have to go into the RGB to HDMI menu, go to the select profile option, and then in this case, because I've been using it most recently, I can just go straight to my recently used section and I can go straight to 2600 Lumacode. And now it switches over to 2600 video mode. And now if I play a 2600 game, it'll be able to lock in and produce a proper image for that. Otherwise, it's not going to look proper. So for now, let's go ahead and let me go back to the 7800 profile. There we go. And I will return from that. And what I will do first is I will start with the diagnostic cartridge. So I'm going to go ahead and power on the 7800. And here we are looking at the diagnostic utility. Now, I'm not going to show everything that's on here, but just enough to kind of show that the console is working and so that we can see an example display of the output. So console information shows it's an NTSC BIOS. It sees the Pokey I have in my diagnostic cartridge, no problems there. Controller test screen is working well, and that looks good. Here's the color display, which is really fantastic on the 7800 Lumacode output. And you can see down here in the match color section that's pretty much dead on, an exact match. And the palette profile that's been used by default is one of the best I've ever seen. A lot of these colors here in the farther hues, where we can actually see these golden colors, tend to look really green on other AV upgrades. So as a result, this is the most accurate color representation I have seen from any kind of video upgrade from the console. And yeah, that's pretty much it. Now the audio test I will go ahead and run because again, I have audio going into that 3.5mm headphone jack that I installed, and that's got both the Lumacode video and the audio coming out of it into the RGB to HDMI, and this has one of the built-in audio capture boards installed. So we should be able to hear the audio, both the TIA and the Pokey, properly balanced. Here we go. Okay, so all of that worked well. So let's see, let's go ahead and check out a 7800 game really quick. Commando is another good one to use because it uses both the TIA as well as the Pokey audio simultaneously in the game, but also this is one of the games that used to show issues with other AV upgrades in relation to the colors, specifically the ground. And you can already see here that we can see the proper coloring on this title screen. And then here we are on the actual gameplay screen, and we have actual brown colored ground once again. On most other AV upgrades, including the UAV that I've installed for nearly a decade now, that would look more green than it should, especially on modern displays. But with the Lumacode and with the palette information that it uses, it looks fantastic. Okay, that's working well. Let's go ahead and check out 2600 stuff. Now again, in order to run this in 2600 mode, we're going to have to change the active profile. So let me go up here to selecting my profile, go back to my recently used, and we're going to go to 2600 Lumacode. There we go. And I will start with the test cartridge for this. Now it does take a second or two for the RGB to HDMI to lock in, but once it does, here we are. We're up and running and we look good. So here we are. We are looking at the 2600 test cartridge, and you know, again, the controls are working well, buttons are working well on this, but mainly it was just to show you that 2600 mode is working properly. So let me go ahead and switch out to my Uno cartridge. Let's take a look at Casey's Gold from Audacity Games. So thank you again for joining me here at the Ivory Tower Collections. Hopefully this information was helpful to you in setting up your own MARIAdigitizer into your 7800 either now or possibly in the future. And also keep in mind that I will have a printable PDF guide in the video description that will go over a lot of the basics that I've covered here as well, just in case that's a format that you would rather look at versus watching through this video. So with that, I thank you again, and I'll catch you guys in the next one.